On this last video for the 3-5 examples, we're going to be solving two more equations from the set that number 28 was from? No, number 30. So we're in the last set of equations to solve. And again, in each of these it says to solve by the method of our choice and then solve it another way, but we will omit that second solution method and just focus on the process of how to solve things that look like these. On number 34, you should recognize this as a logistic equation, and I'm going to start with this one because we want to get to x. We have to get it out of the denominator. You can cross multiply and then divide on this one if you want to, but there's a shortcut if you know your properties of proportions from geometry that says that if a over b equals c over d, that implies that a over c equals b over d. And that's the property I'm going to start with. So I'm going to put 400 over 150 equals 1 plus 95 e to the negative 0.6x over 1. And then when I reduce my 400 over 150, I get 8 over 3 equals 1 plus 95 e to the negative 0.6x. Then I would subtract 1 from both sides, so 8/3 minus 3/3 is 5/3 equals 95 e to the negative 0.6x. And this is where if you multiply both sides by 1 over 95, your fraction would reduce to 1 over 57. And these are calculator questions, but you still need to be able to do these steps, so don't think, well, why don't I just type it in my calculator? Because you won't always have your calculator. We have 1 over 57 equals e to the negative 0.6x. I think I can squeeze one more step down here. So then I'm going to take the natural log of both sides to eliminate the e, and I get the natural log of 1 over 57 equals negative 0.6x, and then the only thing left to do is to divide by negative 0.6x, and so I have x is approximately 6.73842. On number 38, we have another log equation, and this one has logs on both sides. When this happens, you want to apply the log property to the left. That works. And then you want to go back and look at both sides to have them both with the same base. In other words, you don't want anything outside of a log. So on the left we have 2 logs, so we're going to get that down to 1 log by applying the product rule, because the product rule says that the sum of logs is the log of their product. So we're going to do x squared plus 3x minus 10 when we multiply those two together. And then on the right we have a coefficient, which means I can apply the power rule, which would give me the log of 3 squared, which is 9. So then we can apply the one-to-one property, because now I have a log of something on the left equals the log of the same base of something else on the right. It means that I can now drop the logs because what's inside them must be equal. And then because what's inside is quadratic, I'm going to get all my terms on one side, which would give me x squared plus 3x minus 19, which is not factorable. So I'm going to use the quadratic formula. And when I do, I get x equals negative b, which would be negative 3 for this problem, plus or minus the square root of b squared minus 4 times a times c all over 2a, but a is just 1, so the bottom is just 2. And then that cleans up to negative 3 plus or minus, and then we'll get that in a second, over 2. And when you do 9 minus 4 times 19, you add that together because the two negatives cancel, and you get 85. So that's the square root of 85. And again, since this is the x that goes inside a log, we have to go back and look at our domain restrictions for x. And the first log expression would be x minus 2, or we're taking the log of x minus 2, which would move the graph to the right. The domain of that would be, let me switch colors so I'm writing up here in the middle of everything else. I'm going to write this in white. Alright, the domain from this term would be from 2 to infinity, and the domain of this term would be from negative 5 to infinity, and you go with the most restrictive. So our domain is from 2 to infinity, which means that I can only have the positive version of this as my answer. So we exclude the negative 3 minus the square root of 85 over 2. So we're only going to include the negative 3 plus the square root of 85 over 2 as our solution. So when we clean that up, that is approximately equal to 3.10977. And again, I encourage you to stop and substitute these values in, since we omitted the second technique for solving, or use your calculator to graph these equations and verify that when you graph and locate the intercepts, you get what you're expecting. And that's the end of the videos for 3.5.